Yeah, this is Ham Radio Perspectives. I'm Quinn, K8QS.
And Tom, WA9TDD.
Dipole antennas, Tom. Whoa, let's do it. Let's hit some of the things that people may not know about the Dipole antenna. We've used them since we were kids in many, many different fashions on many, many different bands. We love dipoles. Let's start out, Tom, with the simple thing that probably everybody watching knows, and that is the formula for how long the dipole should be. Remember, it's fed in the middle, but what's the total length? And if you do 468 divided by the frequency that you're going to operate on, let's say 7.200 or for 40 meters or whatever it is, and that will give you the length. And then when you make it, maybe think a little bit longer at first and then cut it back because that way you can trim it down. If you make it a little too short, because once you put it up in the air, maybe different SWRs we'll talk about, then you get into trouble. What's number two, Tom?
Number two, that the height dictates the mission, whether you're going to be working distance or near vertical incident skywave. For a standard half-wave dipole, height is everything. To achieve a low takeoff angle for long distance communication, the antenna needs to be at least a half wavelength of the operating frequency you're on above the ground. If it's mounted lower, for example, less than a quarter wavelength, it becomes a near vertical incident skywave antenna, rating its signal almost straight up and bouncing it straight down, which is highly effective for regional communications, anywhere between, next door and 400 miles away.
Yeah, not so great for DX. Okay, number three is the directivity of a dipole. A dipole is not omnidirectional. It radiates more on the sides, broadside, we could say, and then it'll have some areas on the very end of it that will be down quite a bit off the end. So think about that when you put it up. If you have any idea on what direction you want to work, put it up broadside. That should be the best, and avoid those nulls on the end.
Yeah, number four, we've got the multiband doublet approach. While a traditional coax-fed dipole is a single band antenna, resident only on the band it was cut for, and sometimes on the odd harmonics, changing the feed line changes the game entirely. By feeding the center insulator with balanced lateral line or open wire feed line instead of coax, the antenna becomes a doublet. And paired with a capable balanced tuner, which is important in the shack, a doublet can operate efficiently across almost all the entire HF spectrum with minimal feed line loss.
Yeah, it's great. So we did a video on my doublet, I think. And so what I'm going to do is to put a link down below for people who want to know more about the doublet, which is such a great antenna. But again, typically with a doublet, you don't want to feed it with coax. You're going to feed it with window line or open line and get maximum number of bands that you can on it. In some cases, nearly all the HF bands and maybe 6 meters too. And it might be kind of funky, but it might even work on 2 meters. Okay, you never know. I had an 80-meter dipole one time, Tom, that worked on 2 meters.
I believe it.
Yeah.
A doublet is almost what you could consider a non-resident antenna.
Right.
In and of itself, it depends on the tuning end where exactly you can fall with that antenna.
Right. So let's add number five now is on the importance of a balun, little device. I should have grabbed one I've got over here that will go from balanced to unbalanced. Now, in the old days with antennas, everything was balanced. Typically, you would have two wires going up to the antenna and one on either side, woof, woof yourself. And so they were exactly the same. But when we got into the days of coax, which is so easy to use, coax is not like two wires. It's unbalanced. And so it's more like three wires. We won't get into all the theory behind that now, but let's just say that you need something between the coax and your dipole. called a balun, balanced, unbalanced. The antenna is balanced, coax is unbalanced, so you get a balun and you put it up there where you feed the antenna. That's the place that it has to go. And if you can't afford one or you don't want to buy one of those little boxes and put it up there, you can make a number of loops, maybe 12 inches and of the coax, and do that right at the feed point as well. A lot of people do that. It works splendidly. Although you and I have had a lot of dipoles over the years where we didn't have anything by way of a balun. We couldn't afford it. We were just kicking around trying to have fun. And they worked okay. Occasionally, we would get RF coming back down. Okay, dog, be quiet there, please, would you? Okay, hit us with number 6, Tom.
Okay, well, just to interject here,
Sure.
We accept comments from any species, canine, cats, the occasional possum speaks up. But anyway, number 6 is the inverted V compromise, which is kind of interesting because it's still basically a dipole. And you only need one tall tree or a mast for a inverted V configuration. And that's a highly practical solution if you don't have a lot of real estate to spread out a full horizontal dipole. And you hoist the center point high, slope the 2 legs downward to shorter supports. This slightly lowers the feed point impedance, often bringing it closer to a perfect 50 ohms for coax. Makes the radiation pattern more omnidirectional, similar to a vertical, and requires less horizontal real estate.
I love them. In fact, my off-center fed antenna right now is in an inverted V. I had it more horizontal, but I was having trouble with the trees getting in the way, and when the trees were wet and so on, so I made it into a V so I could bring the ends out away from the trees, even though the center is fed up in the tree, literally up in the tree. I used what did I use? A fishing pole or something. I can't remember, to get the wire up over the tree line. So let's do number 7. Dipoles have high voltage on the ends. Okay, low current, high voltage. It's the opposite in the middle of the dipole, but on the end, you got some high voltage. So you may find that if you don't keep the ends away from both people, who can get a nice little shock, the kitty's running around, oh, what's this wire? And or your dog jumping on the end. Yeah. So, and also if the ends are near metal, they can be near wood that's not going to be too much of a problem. Maybe a little bit of a problem if the wood is wet, but generally speaking, you want to keep them away from metal. And I have seen them arcing on the end when they're close to metal and touching metal. You transmit and your SWR goes goofy and you look outside and holy smokes, what's going on here? So that's number 7. Go ahead, Tom.
Okay. And number 8 is the wire thickness that you're forming your dipole with affects your bandwidth. The thicker the wire, the radiating element, the wider the usable bandwidth, the frequency range between 2 to 1 on the standing wave. Thin, stealthy wire works perfectly well for radiation, but will result in sharper tuning on the frequency you're working, meaning that you might have to retune or use an internal transceiver tuner or even an external tuner when moving, say, from the CW end of the 80-meter band, which is really wide, to the sideband end. And Quinn has used extremely thin, invisible magnet wire, like a 32 gauge wire, but
I couldn't even see it.
Yeah, but once you get an ice load on it, now you're replacing. No,
you're right. I'm saying, that's a problem. No. That is a problem. But for stealth purposes, sometimes I have used that wire and then carefully tuned it and limited bandwidth, but hey, it still worked okay. All right, number 9, the surrounding objects. Now, we talked about the high voltage on the ends, and you can get into trouble with that. But the fact of the matter is that if you have any objects at all near the antenna, you will begin to see some changes in the SWR. And if it's like what I have out here with the trees going back and forth close to it, and the trees get wet and they're moving around, then it changes the SWR even more. So think about that. You want to get the dipole out in the open as much as you can, regardless of whether it's horizontal or inverted V. So keep that in mind.
So, and number 10 brings us to, when you're making a dipole, tune it at the operating height. If you're bringing a dipole down and you're laying it on the ground and measuring out your 33 feet on each leg for 40 meters, and boy, it looks really good on your antenna analyzer, and then you hoist it up, 20, 30 feet. That standing wave is going to change because the ground acts as a giant capacitor plate. Lowering the antenna to adjust the wire length changes the resonant frequency. A dipole tuned to a perfect 1-to-1, at 5 feet off the ground will shift its resonance when hoisted to 40 feet. You often have to hoist it to the operating position, measure it, lower it, trim it, hoist it again to dial it perfectly. So plan to spend a whole afternoon working on it to get it to operate correctly.
But that's the fun. That's part of the fun. Then you eventually get that thing at the right height, exactly tuned, and you are rocking and rolling. Dipole antennas, they are part of the history of ham radio, been used for many, many years. They're relatively cheap. You can even get away without a balun. We don't recommend it, but if you have to, you can get away without that. And don't forget, you can use them on any frequency. So if you want to operate 6 meters during a season when 6 meters is hot, rocking and rolling, and you don't have a 6-meter antenna, fear not. Put a dipole up and maybe even an inverted V form out on your deck or something, and it's going to work. So thanks for watching. This is Ham Radio Perspectives. I'm Quinn, K8QS.
I'm Tom, WA9TDD.
Thank you, everybody. 7-3.